This is video number 3, and we are looking at lesson 6-3 at the moment, and conditions for parallelograms. So let's go through, I think, about 6 quick problems. Determine if each quadrilateral must be a parallelogram. Justify your answer. So, of course, you can see the answers as we go, but let's talk through it anyway. If we look at this, we can tell that there's one set of opposite angles that are congruent, but we can tell that there are 2 sets of consecutive angles that are supplementary. So in other words, this one is supplementary to the one before it and the one after it. So that is one of the qualifications for a parallelogram. So the answer is yes to letter A. Now let's look at letter B. Does this meet the qualifications for a parallelogram? This diagram shows us that there's one set of opposite angles that are congruent, but not 2 sets. And our qualification, or our condition in this lesson, tells us that there must be 2 sets of opposite angles that are congruent. So we don't have enough information to go on here to say that this is in fact a parallelogram. All right, let's look. Now this you can actually find in your book. This is page 400, example 2. And here, we're going to again determine if this must be a parallelogram. Well, here we're told that we have one set of opposite congruent sides and one set of opposite sides that are parallel. Our condition in this lesson told us that if we had one set of opposite sides that were congruent and parallel, then it was a parallelogram. But that's not what we're given here. We're given that one set is congruent and one set is parallel, and that does not in fact meet our qualifications, so we would have to say no there. And the next one, looking at this one, at this quadrilateral, we can tell that these diagonals bisect each other into 2 equal parts. So the horizontal diagonal has cut this one in half, and the vertical diagonal has cut this one in half. That is one of our qualifications for parallelograms, that the diagonals bisect one another. So yes, we can call this a parallelogram without any additional information. All right, 2 more quick ones. Same thing, determine if the quadrilateral must be a parallelogram. Well, at first glance, you would probably be tempted to say no on this one. But we do see that we have this set of opposite angles that are congruent. This, we do not have all of that information. But look what we do have. We have a quadrilateral that's been split into 2 triangles. And these 2 triangles have 2 sets of congruent angles each. So this angle is congruent to that one, this angle is congruent to that one. And when we have 2 angles in one triangle congruent to 2 angles in another triangle, we can show that the third angles are congruent to each other by the third angles theorem. So now by angle, 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 we know that this triangle is congruent to this triangle. Therefore, we also can tell that adding these 2 angles is going to be the same outcome as adding these 2 angles. So these opposite angles are now congruent, just like these 2 opposite angles are congruent. So yes, it is a parallelogram. And lastly, let's look at this one. Here, we do not have opposite sides congruent. We have consecutive sides congruent, like a kite. So we cannot say that this is a parallelogram because we have no other information to go on. All right, that's it for this video. Look for another one.